Hello, welcome to the class on transportation problem. We shall see today how optimality test is done. This I shall demonstrate with an example. For this purpose, I have chosen a problem which has appeared in University Examination 10ME74 January 2014 for 10 marks. It is 3x4 transportation problem as we see here, and after checking everything, say balanced, all CIJs are known, and it is minimization and no preferential transportations, and hence I can say that it is already in our standard form. Therefore, we can straight away go for getting an initial feasible solution, and this I have obtained already, and I have an initial feasible solution as you see here, and this is the one which I have obtained it by WAM, which I explained it in my previous class. So this is the problem, and these are the penalties. The first penalty, for example, 1 and 2, there's 1, and 4 and 5, 1. And here in the third row, the minimum value is 6, and I have one more minimum value that is 6. Therefore, the penalty is 0, and so on like that. 5, 4, 3, 3. 5 is highest. I pick this cell, and in this cell, the minimum cost is 2, and I pick this cell and make the decision. Corresponding row, that is supply capability 3 and demand is 4, and put 3 and subtract that, and I carry on. And this is the cell. This is the transportation plan, and I have done. And the associated cost for this happens to be 68 units. Okay. And so before I proceed, I just want to tell this. Please understand the difference between this, whatever the number here you find, and this number. Say for example, this cell is 1 1, and this is what I'm indicating 2. This is C11, and this is X11. Just like that, this is C12, this is X12. Okay, a cell whose Xij value is 0, that cell is called as non-basic cell. And cell whose Xij is not 0, it is greater than 0, all such cells happen to be basic cells. So for this problem here, so X1, this 1 1, this is a basic cell. So here in the first row only one basic cell. In the second row, this cell and this cell, these are basic cells. And in the third row, the 1 2 3, these are basic cells, and this is a non-basic cell. So I just want to count how many number of basic cells are there in this. So okay, as I count, and there are 6 number of basic cells. And what is the m plus n minus 1? M is the number of rows, that is 3, and n is the number of columns, that is 4. So m plus n minus 1, that is 3 plus 4 minus 1, that is also 6. And number of basic cells in this is 6, and this also is equal. Therefore, this solution, whatever I have got, it is not only feasible solution, it is also called as a basic feasible solution. So only a basic feasible solution can be subjected to what is called as optimality test. Okay, now you all may have a question. If the feasible solution is not a basic feasible solution, then what is to be done? Okay, this will lead to what is called as a degeneracy, and this I shall probably explain in another class. Okay, now let me continue, and now this solution is a basic feasible solution, and I can perform what is called as optimality test. Okay, so now I want to explain the optimality test. So this I shall say that I divide it into 3 steps. Okay, and state them in the, say, A, B, C, like that. The first step, so write Cij matrix of only basic cells and find Ui and Vj such that Ui plus Vj equal to Cij, assuming any one Ui or Vj as 0. Okay, appears to be something like a law book or anything like that. So but here it's quite simple. Okay, so now the cross marks wherever I have, so here I also, for your reference, I have kept the solution here, and cross marks I have put here, okay, indicating that they're all non-basic cells, which I'm not supposed to attend to them. Only for basic cells my concern is write Cij matrix of only basic cells. Say for example, the first cell 1 1 is a basic cell. What is the Cij value for this? This is 2. And similarly, in the second row, third cell and fourth cell, they are basic cells. Their Cij values are 5 and 4. Similarly, the last, okay, so the first three cells, this is 7, this is 6, and this is also 6. This is what I have done. Okay, referring to this original table, I have written it here. So I shall bring it back if it is required again. Okay, so now the first part, write Cij matrix of only basic cells, that I have done. Okay, now find U1, U2, U3. U1 is the value for first row, second row, third row, like that, and for columns I am referring them as V's, assuming any one as 0. Okay, so here I shall assume U3 as 0. Suppose I assume U3 as 0. Then I can easily do V1. So make use of U3, which I already know. V1 is unknown, and this is 7. This is nothing but C31. So U3 and V1, if I add these two together, this value is equal to 7. And therefore I can easily say what is V1. V1 is 7. U3 plus V1 is equal to 7. On the same lines I can write down, say 0 plus V2 is equal to 6. Therefore I can straight away write V2 as 6. On the same lines, 0 plus V3 is equal to 6. Therefore this also is equal to 6. Now I can make use of this 5 and V3 and to get what is called as U2. U2 plus 6 is equal to 5. U2 plus 6 is equal to 5. Therefore U2 must be equal to minus 1. Minus 1 plus 6 is equal to 5. So now make use of this U2 and V4 to get 4. What is that? Minus 1 plus V4 is equal to 4. Therefore this must be equal to 5. Minus 1 plus 5 is equal to 4. Now make use of this 7 and 2 to get what is U1. U1 plus 7 is equal to 2. Therefore this is equal to minus 5. So this is the table. This is what I mean by write Cij matrix of only basic cells and find Ui and Vj such that Ui plus Vj is equal to Cij. Assuming any value you can assume, but if you assume 0, then our calculation becomes easy. That is why I have advised you to take it as 0. In fact, you can assume any value. Now let me come to the second step. What is called as find Cij dash, which is equal to Ui plus Vj for only non-basic cells. Now I have put cross for all basic cells. For all basic cells I have put cross. Now let me add U's. So U1 I know that it is minus 5. U2 is minus 1. And U3 is 0. So V1 is 7. V2 is 6. V3 is also 6. V4 is 5. Okay, so now this is ready. Now I am supposed to compute this, what is called as I am first row, second column, C12 dash. C12 dash is the sum of the corresponding U and V. That is nothing but minus 5 plus 6, which is equal to 1. Minus 5 plus 6, which is also equal to 1. Minus 5 plus 5, this is equal to 0. Then minus 1 plus 7, this is 6. Minus 1 plus 6, this is 5. Minus 1, sorry, the last one, 0 plus 5, this is 5. So these are the values which I call them as Cij dash. Cij dash. Okay, then the last step, what is called as cell evaluation matrix. I am supposed to get what is called as cell evaluation matrix. How to get cell evaluation matrix? So cell evaluation matrix is also obtained only for non-basic cells. Therefore first I put cross for all basic cells. So all these cells happen to be basic cells. Therefore I have put cross. Now I am supposed to find out a value, that is first row, second cell. What is the entry here for this cell evaluation matrix? That is nothing but C12 minus C12 dash. So just for your reference, I shall bring it back. And what is C12? C12 is available here 2 or this 2. can see here, C12 minus C12 dash. So what is C12 dash? C12 dash is 1. So therefore 2 minus 1, that is nothing but 1. So then for this cell C13 is 2 and C13 dash is 1. 2 minus 1, 1 again. C14 is 1. C14 dash is 0. 1 minus 0, it is again 1. Then C21 is 10. C21 dash is 6. 10 minus 6, it is 4. Similarly, C22 is 8. C22 dash is 5. 8 minus 5 is 3. And the third row last cell, C34 is 8 and this is 5. 8 minus 5 is 3. This is what I mean by cell evaluation matrix, and these are the entries of the cell evaluation matrix. So based on these entries, we can easily classify or we can conclude. So the conclusions are like this. The conclusion, we can say, if all entries are positive, so as we see here in this problem, if all entries are positive, then the basic feasible solution or whatever the plan we have made, okay, is optimum. And it is not only optimum, it is unique because all of them are positive. Okay, if by chance in the cell evaluation matrix for any other problem happen to be, it is a mix of positive and 0. I don't have any negative entry, but I have few entries positive and few entries, one or more entries 0, and I don't have any negative entry at all. In that case, I can say that the present basic feasible solution is optimum, and it is not only optimum. This is not the only optimum solution. It has multiple optimum solutions. Maybe in some other problem, if it has multiple optimum solution, then how to get one more optimum solution, that I shall demonstrate. Then by chance, if this cell evaluation matrix has say negative entry, maybe 1 or 2 or many number, doesn't matter. Even if it has one negative entry, we immediately conclude that the present solution, present plan, whatever we have made, present feasible solution, present basic feasible solution is not optimum. Okay. So now for the present problem, so all these are positive, and therefore this plan, what we have made now, by this plan is optimum, because all entries of the cell evaluation matrix are positive, and therefore this is optimum, and the associated cost, the optimum cost of this solution is 68 units. So now by chance, if we have negative entry, then it says that the present solution is not optimum. It has to be modified distribution to get the new solution, and that solution is definitely better. Maybe in our next class I shall demonstrate that how exactly we can go on improving, or if the present solution is not optimum. Okay, thank you, be safe, take care.